first player. So this move is a good move. Whenever your opponent does, it's bad for him. Or her. If it's a winning move, it's a winning move. Get that? Stage 2. It is a losing move. A losing move means your opponent, who is very, very smart, has a counter move. Implies your rival has another move, a counter move, that is good for him and bad for you. Now, lemma, any move that your rival can reach from this position, you could have been reached in the first place. Every position reachable from this is also reachable from this. Left to the lecturer, to the audience, and to the lecturer. So once again, you have a winning move. QED. But this proof is very, very unsatisfying. I know that it's an algorithm. You can do the so-called game of the graph, draw all the positions. So let me do an example how to compute the winning and losing. You can label the graph, the game. Look at all the positions. So I know, now I know the winning move. How do I find it? So let's do a simplified case. Only this board. So the winning moves, the legal moves, not winning moves. This, and we take this, and we take this. Now from here, we can go here. So this is called the graph. It's a directed graph of all the game positions. And from here, you go to the poison. Now obviously, this is a losing move. Anything leading to a losing move is a winning move. So I know there exists a way of making your opponent die. That's a winning. But this is a losing move. If every move leads to a winning move for the opponent, it's obviously losing. So this is there. And if there exists an edge leading to an element, so it exists and for all. So we know it's winning. So it's another proof that this is a winning position. But this graph not only tells you that this is a winning position, it tells you what to do. This is what to do. So this is more informative. So this works if n is 2 and n is 2. But if m is 10 to the power 20 and n is 3 times 10 to the power 30, the graph, the size of the graph is big, so big the whole universe will not contain it. So this algorithm is not suitable. So this is very, very unsatisfying. And it's a much better strategy to develop a heuristic machine learning, like in tests, looking ahead 5 or 10 moves and having some ranking, and use heuristics to find out whether it's winning or losing, rather than use this. So in this case, it's once again, it's legit, but completely useless. So it's very, very unsatisfying. But there are worse cases of unsatisfying things in finite mathematics, in which the law of excluded middle is very, very frustrating. So here's another favorite one. And also tells you that you cannot trust doctors. After statistics in general, whenever it tells you that it's not good to smoke, don't smoke, because statistics say that the probability of you living to such an age is much smaller if you do smoke. But this, yeah?
So does the law of the excluded middle, do you accept it here because everything is finite here?
Yeah, I accept it gradually and reluctantly.
Okay.
It's legit, but completely frustrating and useless.
Okay.
And it doesn't do me any good. Except there is a way. If I play against you and I'm friends with, for example, what's his name, Carlson, the greatest drum player in the world, I can do this move and see what he does, counter move, and then I lose against him. But I do copy his move and win against you. So, and so that's. But if I'm big enough, even Carlson won't be able to do it. So it's very actually fine.
What if you look at look at the smallest winning move? I mean, you've got a function from a pair M.
Yeah.
You have many winning moves. Pick the lexicographically smallest one.
Yeah.
This is a function of two variables.
Yeah, but very hard to compute.
Well, but for small m and m, and you would get a collection of sequences.
Oh, I get nothing more, yes. Sure.
Well, I don't know. Have you tried it?
No, it's a good question. Okay. Okay, so here are some examples where it's not satisfying. Well, one famous one is Pascal. I like Pascal because Pascal's triangle and also Pascal's hexagonal theorem, but Pascal was also a born-again Christian, and he had the proof why you should believe in God and in Jesus. Because there are two cases. Case one, God exists. Then if you sin, you rot in hell forever. If case two, God doesn't exist, so if you still live a good life, you don't lose anything, so you may lose some pleasure. But since the punishment is infinity, negative infinity, he says it's still good to behave. But of course, this is completely flawed, but never mind. I'm not going to argue with Pascal. Okay. But another similar, more profound paradox, where you abuse the law of dual middle for finite cases, is Newcomb's paradox. Another beautiful paradox. And Newcomb's paradox. So once again, it's about a God who can predict everything, who knows what you're going to do. So there are two cases, two boxes. Box A, that you can see what's going on. Box A has $1,000. And box B, you don't see. And God would decide whether to put nothing or put $1 million. Now, if you gonna pick A and B, and God will predict it and put nothing. If you're only gonna do pick B, then God will predict it and put $1 million. So by the law of excluded middle, it's good to pick both boxes. And here goes the stupid argument. So I took it from Wikipedia. So there are four cases once again. Okay. The predicted choices, predicted, what God will predict, and the actual choice. Oh, sorry, I need to move on. So go to the table, and using flawless logic, the law of the middle, you can prove you should pick both boxes. It is stupid. Predicted choice and actual choice. And then the payout. So let's have the table. If your actual choice is A and B, and God predicts there is A and B, then you get only $1,000. If your actual choice is B only, but God will mess up and predict A and B, you get $0. If the actual choice is A and B, and God will predict only B, you get 10 to the power 6, but 10 to the power $3. And finally, if the actual choice is B only, and the predicted choice is a B only, then you get 10 to the power 6. So here goes newcomer. Case 1 and case 2. If the actual choice is A and B, then this then this is bigger than this. Yeah, this is bigger than this, and this is bigger than this. So whatever you do, whether the predicted choice A and B, case 1, case 2, it's always good to do A and B. But this is flawed, because God is not everything. So this can never happen. And this can never happen. So you should be nice and only, don't be too greedy, and only pick B only. So this is flawed, because, and even if God is not completely almighty, with probability, it messes up sometimes, the expected gain is still much bigger if you do B only. So in this case, one of the cases can never happen, or it's very unlikely to happen, so this is flawed. So this is one example of very unsatisfying things. Another example is a beautiful paradox that tells you you can't trust doctors. Like, oh yeah, Jane interrupted me about smoking. When you are told that not to smoke, you assume that you are the same. You are equally likely, like anybody else, the population. But you are unique. It's very possible, so for you, smoking will be beneficial. In fact, I know at least one example, that smoking can save your life. There was a terrorist attack in Israel about 20 years ago in a public Buxoro, and of course you cannot smoke inside. So somebody went outside to have a smoke, and then the terrorist attack, and everybody there died, but because he smoked, he went. So smoking may save your life. So you should take everything with a grain of salt. So the symptom paradox is about some treatment. Never mind the detail. Small stones and large stones, kidney stones. So you have two kinds of treatments. So never mind the numbers, but for treatment A and treatment B. So case 1 and case 2. In treatment A is better than B. Also for large stones. So the logical conclusion was that since you either have small stones or large kidney stones, A is not B. But if you look at the overall statistics, treatment B cures more people. So it's another case. So you can say, if you definitely know that you have small stones and large stones, and everything is equal, everybody with small kidney stones is equally likely to be, then you may have a point. But there are so many other factors. You can have diabetes or this. So, in other words, every time you hear statistics by doctors, take it with a grain of salt. It's all based on many assumptions that may not be true. And an even more striking example why the law of excluded middle should not be used even for final tests is a very famous prisoner's dilemma. I'm sure you know about it, but let me remind you. Once again, because they use the law of excluded middle to get very unsatisfying conclusions. But nevertheless, game theories say are inevitable. So you have two prisoners. Let me remind you, I'm sure most of you know about it, but it's good to be remembered. You have two prisoners, A and B, that commit a crime together. Now, the police gives them a deal to talk, to tell the other one to be a thing, to defect, or to keep silent. So here are the rewards. Prisoner A is silent, or prisoner A talks. That's the options for A. The option for B is be silent, be nice to your crime mate, not tell on him, or be the state witness and talk. And here are the rewards. If they are both silent, the boss only gets 1 year, because they cannot prove that they committed the murder or the big robbery. They only have some very minor things. So you can only give them 1 year each on some very minor things. Now, if A is silent and B talks, B will get free, 0 years. That was a deal with the DA, district attorney. But poor A will get 3 years. Or you can make it more dramatic, 30 years. If A talks and B is silent, A will get 0 years. But B will get 30 years, not in jail. And if the boss talk, the ace gets 20 years. Okay, let's say 10 years. Obviously, if they're nice, they won't talk. First, it's not nice to talk, to tell on you things. But according to the flawless logic of game theory, both of them would talk. Because case 1, B is silent. So if B is silent, 0 is better than 0 is better than 1 year. So A should talk. If B is silent, if B talks, then once again, 10 years is better than 30 years. And by the same argument exactly, both of them would talk and get 10 years. But if they are coordinated, they will only get it 1 year. So that's an example where it felt unrealistic because they have families and they belong to the mafia. So if they find out one of the other, they can take it out on your family. So I felt it's very unrealistic, the whole game theory. But also, instead of doing narrow-minded, greedy rationality, you should replace it by meta-rationality. So even though you don't have a formal agreement, you can have a tacit agreement. So forget about the stupid law to the middle and be nice. And it's also, and this is what I would choose. And if by this, if I get 30 years and they talk, God will punish him. Thank you very much.